HiPerDry, a novel microwave-enhanced superheated steam process for high-performance drying of hygroscopic polymers. Drying is the most energy-intensive step and requires around 20% of the overall energy consumption within the processing chain of hygroscopic polymers. Annually, over 10 million tons of hygroscopic polymers, both fossil and bio-derived, are processed into technical thermoplastics used in the European automotive, aerospace, and the electronic goods sectors. Raw materials for fossil-derived polymers are decreasing. Consumption patterns are thus increasingly changing towards bio-derived polymers, towards more environmentally responsible and sustainable products. Biopolymers are estimated to gain market shares of 10% in packaging and consumer goods sectors, and even up to 40% in the sector for automotive interior components in 2020. Despite the increasing importance and market demand, processing characteristics of thermosensitive bio-derived polymers are not fully understood and explored. The development and processing of bio-based polymers, though still a niche market, have recently gained a crucial importance. Main limitations are given by thermosensitive raw materials and partial degradation occurring due to incorrect drying.
Here in HiPerDry, we use hygroscopic polymers, and we need to remove the humidity before to inject the parts. And we need a cost-effective solution and time-saving.
HiPerDry aims to improve the overall energy efficiency during the drying process. The main objective of HiPerDry is to enable significant energy and time reduction in drying of hygroscopic polymers of 30 to 50%, and to efficiently dry temperature-sensitive hygroscopic polymers, especially biopolymers, without the risk of material degradation.
The consortium of the project is a European consortium from among Europe, and we have especially partners from the SMEs associations, and also a pilot plant like HiPerDry, who is testing the results of the research, of this research. And the University of Stuttgart, and also in collaboration with Fraunhofer Institute, we are responsible to develop the technology, but also to transfer this technology to the companies.
A further objective is to enhance the knowledge base of the hygroscopic polymers processing industry through SME AGs and their members by publishing best practice guideline on drying of hygroscopic polymers.
So for our membership, for those that will be interested in this kind of technology, there'll be two very large advantages going forward. One will be the time saving that this technology provides over current solutions, and the other advantage will be energy savings. Those two items alone will show cost benefits over the life cycle of this technology that will make it advantageous to buy.
The HiPerDry Consortium consists of 12 partners from different European countries to develop and demonstrate a prototype drying system to enable gentle drying of hygroscopic polymer granules.
So we have been in charge of the testing of the machinery. So we performed a series of tests with different kinds of polymers in order to validate the performance in terms of drying time, but also energy consumption. And we used for that different polymers like polyamide, but also bio-based polymers like PLA.
The simultaneous combination of microwave and superheated steam in drying of hygroscopic polymers yields to higher drying rates. This is achieved by enhanced mass transfer of evaporated moisture into superheated steam atmosphere. But also the supply of latent heat for evaporation can be done effectively and selectively to the water molecules by microwaves. Temperature gradients within the polymer granules are reduced. leading to homogeneous removal of bound water and avoiding local and surface overheating while decreasing the drying retention time.
We did not only check for how the dryer performs in comparison to a state-of-the-art dryer, which showed us that there is capacity and potential for savings in time up to 60% and also savings in energy up to 30%. But we also made sure that the polymers do not suffer any strain from the microwave application, for instance.
The project outcomes will support the entire plastic supply chain in efficiently processing of high-quality hygroscopic polymers and biopolymers. Thanks to EC for funding.